This conference will now be recorded.
Hello everyone. Today we'll start with a problem. Potassium permanganate, which is very important reagent. This reagent already we have discussed in last class, and some problems related to this reagent we will discuss now. And after finishing this, there will be another important reagent, which is potassium dichromate, that is K2Cr2O7, and that reagent is also highly oxidizing in nature, just like KMN. So the problem is saying, this assertion, reason type of problem. Assertion, the statement is saying that in the reaction between potassium permanganate, that is KMnO4, and potassium iodide, that means Ki. So there is reaction between KMnO4 and Ki. In this case, permanganate ions are acting as oxidizing agent. Now we know that KMnO4, it is highly, that is very strong oxidizing agent, and here oxidation state of manganese is +7, which is the maximum oxidation state possible for manganese. And Ki means it is source of iodide. That means here I- will act as reducing agent. It will supply electron towards Mn+7. So Mn+7 will accept electron from iodide, and it will itself be reduced to some lower oxidation state. So this statement is correct. There is nothing wrong in it. Now the second statement, which is mentioned in reason, it is saying that oxidation state of manganese is changing from +2 to +7. That means before reaction it is +2, and after reaction it is +7. But see, KMnO4 is oxidizing agent. It will always accept electron. But if you look carefully, the conversion of +2 to +7, it is basically loss of 5 electron, which is not possible at all. Okay, so oxidation state of manganese, basically it will decrease from +7. It will achieve some lower oxidation state because it is accepting electron. Mn+7, it will accept some number of electrons. Suppose it is n number of electron, so always this +7, it will be decrease. Okay, but here in this statement it is mentioned from +2 to +7. That means it is loss of electron, loss of 5 electron, which is not possible. So whatever is the number of electrons, even that is also not important. Just from the statement we can easily understand that this statement cannot be correct, because conversion from +2 to +7 is nothing but loss of electron, which is oxidation. But KMnO4 itself is oxidizing agent. It cannot be itself oxidized. It will be itself reduced to some lower oxidation state. So that is why the reason statement that is given, that is not correct. Now if we see actually that we know that there are different, depending on what kind of condition of the reaction you are considering, whether it is acidic, basic or neutral, depending on that, this number of N, that is how many electrons it will accept, that may vary. But even if you do not cannot remember that, then also we can say that option 3 will be correct, because the first statement is correct, statement in assertion, but the second statement is not correct. But if we see what is the number of N when we are using different medium. So here we have two equations. Both the equations are basically the reaction between KMnO4 and Ki. Okay, so this is molecular equation, and this is in neutral medium. And the second equation, it is ionic equation, because here we are using ions. But the common thing is, in both cases, KMnO4 will act as oxidizing agent and Ki will act as reducing agent. So here it is +7. In neutral medium, it will be converted to MnO2, that is +4 oxidation state. And the fate of I minus, now it is converted to KiO3, that means iodate ion, IO3 minus. And here oxidation state is +5. But if it is acidic medium, now oxidation state is changing from +7 to +2. Fine. And I minus, that is now oxidized to I2. So in the previous equation also I minus is oxidized to from -1 oxidation state to +5, and now it is conversion from -1 oxidation state to 0. So both are basically oxidation. But whatever it is, even without writing this equation, we can easily understand that the second statement, that is not correct at all. So here option 3 will be the correct option. So any doubt in this question?
No, ma'am.
Okay. Next question, that is also related to KMnO4. Here we have one equation given in the question, which is in alkaline medium. Reaction between KMnO4 and potassium hydroxide. The balanced equation is already given in the question, and conversion of KMnO4 to K2MnO4. K2MnO4 is potassium manganate. KMnO4 is potassium permanganate, and K2MnO4 is potassium manganate. Okay. Here oxidation state is +7, and here it is +6. That means from +7 to +6, it is accepting 1 electron only. And in the question it is asking equivalent weight of KMnO4. Now if we want to know what is the equivalent weight, first we have to know what is the molar mass. When molar mass is known, the next step that we have to do, that in the reaction medium how many electrons are accepted or lost. So in this case Mn is changing its oxidation state from Mn +7 to Mn +6. So this is acceptance of 1 electron plus 1 electron. Now when it is 1 electron only, then how to find out the equivalent weight? So suppose in general if we write it is n number of electrons. Okay. So molar mass, that will be divided by this number of electrons. So molar mass divided by n. But in this case n is equal to simply 1. So molar mass and equivalent weight both will be same. So see, equivalent mass, general formula that we will use, it is molecular weight divided by how many number of electrons are gained. So as it is oxidizing agent, it will gain electron. But suppose if it is for any reducing agent, then it will be number of electrons lost. But the main thing is equivalent mass, it is related to molar mass. How? It is by this formula, molecular weight divided by number of electrons. Now number of electrons in our case, it is simply 1, and molar mass of KMnO4, that is 158. Now as it is 158, that means equivalent weight will be 158 divided by 1. That means it is same. Okay. So the number of electrons gained per molecule of KMnO4, it is 1. So that is why equivalent mass and molar mass both are same. And from the formula of KMnO4, you can easily calculate how we are getting this 158 value. Okay. So here correct option will be the last option. Similarly, suppose the equation which is given in the question, instead of the conversion from KMnO4 to K2MnO4, if it is converted to MnO2. So in that case, the final oxidation state of manganese, because it is MnO2, so here oxidation state is +4. That means from +7, now it is converted to +4. So number of electrons gained, that is 3. So in that case, it will be molar mass divided by 3. So this is another example I am talking about. But in this case, it is 1. So that is why both molar mass and equivalent mass both are actually same. Fine. Next, we are starting another important reagent, which is also the compound of potassium. The previous reagent, that is also compound of potassium. This one is also compound of potassium, but now the anionic part is different. It is potassium dichromate. In the previous case, it is AnO4 minus, but now it is Cr2O7 minus. First, we will see how we can make it. And here, the how it looks, appearance is given. It is orange crystal ionic compound, and the formula is K2Cr2O7. So see here, 2 potassium ion, that is 2 positive charge and 2 negative charge present over these 2 oxygen. So this is Cr2O7 unit, that is the anion. So 2 negative charge balanced by 2 positive charge. How we can prepare it? We will use the chromite ore. Now chromite ore, it is having formula FeCr2O4. It is used to make this compound. The first step is, it is not that directly in single step you will get the final compound. There are several steps. So here the first step is, what we are trying to make? We are making sodium chromate. Now dichromate ion is Cr2O7 2 minus. But when we are saying chromate ion, it is basically CrO4 2 minus. So see, formula is different. Cr2O7 2 minus or CrO4 2 minus. But oxidation state is same in both the cases. Only the formula is different. Now FeCr2O7 in presence of sodium carbonate and oxygen, first it will be converted to sodium chromate, Na2CrO4. And the fate of iron is, it is converted to oxide, and carbonate ion, now it is converted to carbon dioxide. This is the first step. Now in the second step, this sodium chromate, it will be okay. Before going to the second step, see how it looks. That is, I'm talking about Na2CrO4. So Na2CrO4 to sodium ion, and this part is CrO4 minus 2. It looks, it is deep yellow crystal. Now this molecule, it will react with H2SO4 and it will be now converted to Na2Cr2O7. That is, the name of this molecule is sodium dichromate. Fine. So this is the second step. And the third step is, finally the cation sodium, that will be changed to potassium, because we have already reached the anion Cr2O7. Only we have to replace sodium by potassium. And as a source of potassium, what we are using? We are using potassium chloride salt. And finally, we are getting K2Cr2O7. So this K2Cr2O7, this is also orange colored crystal. And if we want to know what is the color of K2CrO4, that means potassium chromate. So see, this is potassium chromate, and it is having the same appearance as we have seen from sodium chromate. Na2CrO4 and K2CrO4, both are, it looks same. Okay. Now these two types of ions, one is chromate, another one is dichromate. Chromate is CrO4 2 minus, dichromate is Cr2O7 2. In both cases it is plus 6 oxidation state, but these two anions, they are actually interconvertible in aqueous solution depending on what type of pH you are using. So suppose you have CrO4 2 minus ion, if you are increasing the acidity, that is you are adding H plus, it will be now converted to dichromate. Similarly, if we again want to convert dichromate to chromate, what you have to do? Now you have to increase the pH. That means you are now making the medium alkaline, and now it will be again converted to chromate. So in this way, depending on whether the medium is acidic or basic, they can interconvert to each other. And remember, in both cases, oxidation state is same, only the anion, its formula is different. Okay, so is there any doubt how we can make potassium dichromate starting from chromite ore and following 3 different steps? Okay, and this chromate ion, it is tetrahedral. That is, I'm talking about this part. It is tetrahedral, and if we consider dichromate ion, see, this is dichromate ion, and dichromate ion, it is basically as if 2 tetrahedral unit sharing one corner with CR bond angle 126. So just look at this position. This angle is 126. So as if this oxygen, it is shared by 2 chromium, 2 metal atoms simultaneously. Okay. If you take 2 CrO4 and you remove one oxygen, and one oxygen will be shared between these 2 chromium metal, then you will get dichromate. And here this bond angle is 126. Fine. Now, after preparation of potassium dichromate, next we will see its properties, physical properties and also chemical properties. Remember, it is a very strong oxidizing agent. It has melting point 671 Kelvin. So it is in Kelvin scale. If you convert it to degree centigrade, it will be somewhere around 400 something. Okay. So see, this is having a very high melting point because it is ionic compound, crystalline compound. Okay. Highly soluble in hot water. But if you are using cold water, it is moderately soluble. Action of heat. When we are heating this compound, there will be decomposition, and it will decompose to K2CrO4, and also oxide of chromium will be produced, and evolution of oxygen gas. So when K2CrO7 is decomposed, we are getting 2 chromium compounds, K2CrO4, Cr2O3, and also we are getting oxygen gas. As it is very strong oxidizing agent, so see, in acidic solution, its oxidizing action, how we can represent it? Cr2O7 2 minus, in acidic medium it will be converted to 3 plus oxidation state. So from plus 6, now it is converted to 3 plus. And how we are calculating this plus 6? It is very easy. So suppose it is X, that is oxidation state of chromium. If it is X, so it will be 2X plus, there are 7 oxygen. For each oxygen, it is minus 2. So 7 into minus 2, and overall charge is 2 negative. So X value, it will be 7 into 2, that is 14 minus 2, 12. 12 by 2, it is 6. In this way, you can easily calculate the oxidation state. So from plus 6 state, now it is converted to plus 3. That means it is gain of electron. And here E naught value, that is the reduction potential value for this system, that is also given 1.33 volt. Okay. And how we can balance this half reaction? Because it is not the complete reaction. Here the reducing agent is not mentioned. It is only the half reaction. Because if you consider redox reaction, there is one reduction reaction, another one is oxidation reaction. So here only the oxidation reaction is, reduction reaction is mentioned, because chromium is accepting electron and it is reduced to some lower oxidation state, which is 3 plus. Now how we can balance it? See, here we have 2 chromium atoms in the left hand side. So that is why we have written 2 here. And what is the number of oxygen? It is 7 oxygen atom. So to balance number of oxygen, what we have done, we have added 7 water molecules. Now when you are adding 7 water molecules in the right hand side, you are also adding 14 hydrogen. So you also have to add 14 hydrogen in the left hand side. So that is why it is written 14H plus. Now it is in acidic medium. Now you cannot write HO minus because it is not acidic, it is not alkaline medium, it is acidic medium. So that is why you, when you are writing hydrogen, you have to write it in terms of H plus. Next, how to understand that 6 electrons are involved? That is also very easy to understand. See, to understand that how many electrons you will add, just look at the charge. 14H plus and 2 negative. That means in the left hand side, what is the total positive charge? It is 12 positive charge in the left hand side. Now look at the right hand side. Total positive charge 3 plus, but there is 2, that means it is plus 6. So 12 positive charge in the left hand side and 6 positive charge in the right hand side. If we want to balance it, we have to add 6 negative charge, that means 6 electrons should be added. Okay, in this way we can balance the half reaction. And try to recall the half reactions that we have seen in case of potassium permanganate. In case of potassium permanganate, we have 3 different equations for 3 different medium: acidic, neutral and alkaline. But when it is K2Cr2O7, there is only one equation, that is only acidic medium is considered, not alkaline or neutral. We have some examples here. Cr2O7 2 minus, that is the anion is mentioned, because all these reactions are not molecular equation, they are ionic equation. So we are focusing only on the anionic part, not that is potassium is not mentioned. So see all these equations, there will be Cr2O7 2 minus, and in the right hand side you will always find chromium 3 plus. So this they will be always present. But different equation, there are different reducing agent. In the first equation, there is sulfite ion, SO3 2 minus. SO3 2 minus converted to sulfate ion. Here oxidation state is plus 6. Okay. But if we look at sulfite, here oxidation state is lower than this. That means it has lost electron. Okay. It will be plus 4. So from plus 4 state, now it is converted to plus 6. That means it has lost electron, and that electrons that are given by sulfite, that electrons are accepted by Cr2O7 2 minus. Second equation, here the reducing agent is chloride ion, Cl minus. After giving electron towards Cr2O7 2 minus, chloride is converted to chlorine. That means 0 oxidation state. Initially it is -1 oxidation state, now it is 0 oxidation state. And number of hydrogen, how we are getting this? You can easily write the total equation, that is the total redox equation. Just write the half reactions individually, and then you have to add the two equations. In this way you can get the complete equation. In the third one, the reducing agent is nitrite ion, that is NO2 minus, and NO2 minus is converted to nitrate. Here oxidation state is plus 3, but after giving electron, here it is plus 5. That means it is nitrogen is oxidized. The fourth equation, we are using thiosulfate ion. Thiosulfate ion, it is also converted to sulfate ion. And the last one, Tin2 plus, Sn2 plus, this is stannous ion, and after reaction, now it is converted to stannic ion, which is the higher oxidation state of tin, that is 4 plus. So all these are examples of the oxidizing power of K2Cr2O7. Reducing agents are different: sulfite, chloride, nitrite, thiosulfate, and Sn2 plus. So is there any doubt in this slide? After oxidizing power, next we will see how it can react with H2O2, that means hydrogen peroxide. Acidified solution of dichromate ion, that means Cr2O7 minus. It forms a deep blue color solution when it is reacting with hydrogen peroxide. And this that is, what is the reagent, that is compound that is responsible for this blue color? It is because of the formation of CrO5. So see here, after reaction with H2O2 in acidic medium, we are getting CrO5 and water. Now here we have the structure of CrO5. There are two different types of oxygen are present. One oxygen which is directly attached to chromium by double bond. Okay, so for this oxygen here, oxidation state for oxygen is -2. It is oxide. But if you look at this linkage, which is basically peroxide linkage, here oxidation state of oxygen is -1 -1. So if you consider this formula, and if you are thinking that all the oxygens are -2 type, then you are wrong. Why? Because if you are considering -2 charge for all these 5 oxygen, total negative charge will be -10. That means chromium must have oxidation state +10, which is highly unlikely. It is not possible at all. That means here two different types of oxygens are there. Fine. So see, total negative charge -2 here and -1, it is 4 times. That means total negative charge is -6, which is balanced by the +6 oxidation state of chromium. So if it is asked what is the oxidation state of chromium, in chromium O5, the answer will be it is having +6 oxidation state. So basically oxidation state is not changed, because in Cr2O7 2 minus anion also the oxidation state is +6. Fine. So see, this is the structure of CrO5 minus. Any doubt? Next important reaction, which is also known as chromyl chloride test. Why the name is such, that is test? Why the word test is used here? It is because this reaction is used for the identification of chloride ions in qualitative analysis. So suppose you have any inorganic salt. Suppose you have any salt of potassium and you want to know whether the anion is chloride or not. If you are not sure about it, then what you have to do, you have to perform this test, and if the test is positive, that is the proof that chloride ion is present. So that is why the name is chromyl chloride test. This is the identification test for chloride. How we can do this test? First, you have to when heated with concentrated HCl or with a chloride salt in the presence of sulfuric acid. That means the unknown salt, here we have already written chloride salt, because if it is not chloride salt, it will not be positive. So the salt is chloride salt. It may be NaCl, it may be KCl. We also have to use concentrated HCl or with a chloride salt. That means either you use HCl, which is source of Cl minus, or you can also use NaCl or KCl, which is also source of chloride. And acidic medium is required. For that purpose, we are using sulfuric acid. So either concentrated HCl or chloride salt, not both together. Any of these will be used as source of Cl minus. Now what will produce? There will be production of reddish brown vapors of chromyl chloride. So see, this is the formula for chromyl chloride. What we are using, obviously we are discussing potassium dichromate, so this reagent must be present. And this is the source of chloride. Here we have taken NaCl, you can also take HCl or KCl. And for acidic medium, we are using H2SO4. In the product side, what will be produced? HSO4, NaHSO4, and the main compound which is responsible for these orange red colored fumes. This compound is CrO2Cl. Remember, whenever we are talking about any detection test or identification test, there must be some visible change. It may be change of color or disappearance of some color. It may be evolution of some gas with a specific smell. Sometimes it may be some colored gas is produced. Sometimes it may be precipitation. Okay, so in this case, that is in our case, it is production of reddish brown colored vapor, which we can easily see by our naked eye. Okay, so because of this type of observation, this can be used as the detection test of chloride. Now, this is not just end of this test. So orange red colored fumes that you can easily understand, which will be coming out from the test tube. Now, if we are passing this gas through the solution of NaOH, so when you are seeing that orange red fumes are produced, it is fine that now we can understand chloride ion is present. But to further confirm our observation, next what you can do, you can pass this gas through the solution of sodium hydroxide. Now, what will happen when we are doing so? CrO2Cl2, it is passing through NaOH, and we will be getting Na2CrO4. And this solution, remember Na2CrO4, how it looks? It is yellow colored crystal. So the solution will be now yellow solution. So this is another evidence that the brown colored gas that is obtained, that is nothing but CrO2Cl2. And this is second observation. This is first observation, number 1, that you are seeing orange red fumes. Second observation, you are getting yellow solution. And the third observation is, if this yellow solution of Na2CrO4 that is obtained after passing through NaOH, if it is treated with lead acetate. What is lead acetate? It is Pb and 2-acetate anion attached to it. So if you are adding this compound to this yellow solution, there will be further precipitation. So try to understand the difference. This is yellow solution because Na2CrO4, it is soluble in water. So it is transparent solution which is yellow color. But when you are adding lead acetate, now the cation Na is changed by the cation Pb2+, and this molecule that is PbCrO4, it is not soluble. So that is why you will observe some yellow colored precipitate. So there are basically total 3 observations. First, there is evolution of reddish brown vapor of CrO2Cl2. Next, you can see yellow solution if you are passing this gas through NaOH. And the third observation is, if you are adding lead acetate to this yellow colored solution, there will be yellow colored precipitate. So this is the chromium chloride test. So is there any doubt how we can perform chromium chloride test? Is it clear? Application of this reagent, that is K2Cr27. The first application, obviously it is used as oxidizing agent, because just like KMnO4, this is also very strong oxidizing power. In photography and in hardening gelatin film, in dyeing for use as mordant, then that is dyeing when there is what to say, in dye industry, this can be used as mordant, that is to intensify the color that is generated. This is used. Chromic acid mixture, that is K2Cr2O7 and with the presence of concentrated H2SO4. This mixture is used to clean glassware in the laboratory because it is highly oxidizing mixture. So if there is some impurities left after doing reaction, when we clean the glass apparatus in the laboratory, then this mixture is used. to clean the glass apparatus. Okay. Leather industry, potassium dichromate is used in chrome tanning. Then volumetric estimation of ferrous salt. Remember, volumetric estimation we have already seen in case of KMnO4, where by volume titration we have seen that how we can estimate the amount of Fe2 plus that is present in the salt. So this is quantitative test, not qualitative, because we already know that there is presence of Fe2. But suppose you want to know what is the amount of Fe2 plus, then volumetric estimation is done, and in this case after oxidation it will be converted to Fe3 plus, and this oxidizing reagent, that is actually either KMnO4 that we have already seen when we have discussed KMnO4, but it can be also potassium dichromate. So not just Fe2 plus, it is also can be used for estimation of I minus or sulfite, that means SO3 2 minus. Fine. For the preparation of other chromium compounds such as chrome alum, K2SO4 dot Cr2SO4 whole 3 dot 24H2O, or chrome yellow, which is the name of PbCrO4, and chrome red, which is PbCrO4 dot PbO. So for the formation of all these compounds, that is for synthesis of all these compounds, as a chromium source, you can use K2Cr2O7. So all these are applications of this reagent. Fine. Here we have a problem. Consider the following reactions: NaCl reacting with K2Cr2O7 and H2SO4. See, this is nothing but chromium chloride test, because in chromium chloride test we take some source of Cl minus. It may be KCl, it may be NaCl, or it may be HCl. And acidic condition, so H2SO4 is used, and potassium dichromate, that will obviously be there. A plus side product, but we are interested only in A, because this A, which is obtained in first step, now it is used in the second step. A is reacting with NaOH and we are getting B and some other side product. Then in the third step, this B is again reacting with H2SO4 and H2O2, and what we are getting? We are getting C and some side product. But here we don't just have to recognize what is ABC, but we also have to find out what is the total number of atoms that is present in each molecule of ABC. So our first step that we have to do is to find out what is A, what is B, what is C. And finally, after that is recognizing ABC, next we have to count the number of atoms. So here A is nothing but chromium chloride, that is CrO2Cl2. Total number of atoms present 1 plus 2 plus 2, that means 5. Now this chromium chloride, these are the side products, NaSO4, K2SO4. This CrO2Cl2, that is A, now when it is passing through NaOH, remember we get yellow solution which is Na2CrO4. Now this Na2CrO4 finally reacting with H2O2 in H2SO4 medium. So in chromium chloride test, in the third step, what we have done, we have added lead acetate, but in this case it is different. After this second step, this is number 1. Number 2, in the third step, what we are doing, we are treating B with H2SO4 and H2O. Remember, we have already discussed how K2Cr2O7 reacts with H2O2. Remember this slide? That is the first reaction. So here Cr2O7 reacts with H2O2 in acidic medium and it is converted to CrO4. But in our question, instead of Cr2O7 2 minus, now we have Na2CrO4. That is the only difference. But the important point is, chromium is having same oxidation state in both the compound. In K2Cr2O7 also it is +6 oxidation state, and in this case also, that is Na2CrO4, it is also +6 oxidation state. So that is why the compound that we are getting, that is same compound. CrO5. So in CrO5, that is C, total number of atoms present 6, 1 plus 5, and Na2CrO4, 2 plus 1 plus 4, that means 7. So we have to add these 5 plus 7 plus 6, that means 12 plus 6, it is 8. So the sum of total number of atoms in one molecule each of ABC, it is 80. Okay, so this is an integer type of problem. There will be a, that is the answer is whole number. Any doubt? Next question, that is also related to chromium. Here we have 4 options, all are chromium compounds, right? But we have to find the ionic radius of chromium, in which case is minimum. That is the question. Now, ionic radius, when we are talking about, obviously we have to consider chromium ion, that is chromium carrying some positive charge, suppose it is N plus. Now when N value is very high, that means highly electron deficient chromium, so the size will be smallest. So lower is the value of N, higher is the value of N, then lower is the minimum will be the size of the ionic radius. Okay, because when charge is very high, size will decrease. Remember, suppose you have taken any atom A, you are removing one electron, you are getting A plus. You are removing another electron, you are now getting A2 plus. So if it is asked, compare the size of A plus and A2 plus. Obviously, size of A2 plus is smallest because it is carrying 2 positive charge. So basically in these 4 options, all are chromium compounds. We have to find out the oxidation state, and when the oxidation state is very high, that in that case chromium will be having minimum ionic radius. So in the first compound, it is very simple. It is +3 oxidation state because 3 fluoride ion are there. In the second one also this is +3. In the third one also it is +3 because 3 oxygen atom, each oxygen is -2, so -2 into 3, total negative charge -6. So 2 chromium, total positive charge +6, but as it is 2 chromium, it will be +3. And in the last one, K2CrO4, which is potassium chromate, it is +6. So the first 3 options all are having same oxidation state +3, but the last one, it is having the highest oxidation state. So that is why ionic radius of chromium, that will be minimum in case of last one. So here correct option is this one. Okay. Any doubt in this question? Then we'll go to the next one. Which of the following compound will not give positive chromyl chloride test? So to answer this, we have to understand the principle of chromyl chloride test. If you want to get positive chromyl chloride test, there must be presence of free chloride ion. Okay. Now free chloride ion, when you can get? If it is ionic compound, there will be some dissociation. Now come to the options one by one. CuCl2. Now this is ionic, so here you can get Cl minus ion. Okay, so this will give positive test. So this is not the correct option because we have to find that option which cannot give positive test. Then the second one, AgCl2. This molecule is not ionic. This is covalent. Now how to understand this is covalent? We will come to that point. Just know that right now that AgCl2, as it is covalent, it will not dissociate like CuCl2 and it will give free chloride ion. So that is why it will not be able to give positive test. So this is actually the correct option. And the third one, why it is also giving positive test? Because this is also ionic, it can give Cl minus ion. And the fourth option, See, this is actually organic compound. C6H5 NH3 plus Cl minus. Now C6H5 is benzene, and this is the structure of aniline, and when you are adding HCl to it, then NH2 will be protonated, so now it will be NH3 plus and the counter ion is Cl minus. So see here, NH3 plus Cl minus, these two are actually there is ionic bond, so free Cl minus ion is present. So at a first glance it seems that it is organic compound, then how it can give chromium chloride test? But remember, chromium chloride test will be positive if free Cl minus ion is there. So in this case it can give free Cl minus ion, so that is why it will also give positive test. That means it is not the correct option. So the next question is, why among these three compounds, because all are same kind of compound, then why specifically HgCl2 is not giving the test? What is the reason behind it? Before going to this, just look at the cation. Cu2 plus Hg2 plus Zn2 plus. All these metals, they are from the same, that is not same group, I mean to say they are from D block, right? Now when they are from D block, copper and zinc, these two are in the first transition series. And copper and zinc, this is group 11, this is group 12. And just below zinc there is cadmium, and below Cd there is Ag. That means mercury and zinc, they are in the same group. Okay, this is important point. Now come to this explanation. Zn, Cd and Ag. This is from first transition series, second transition series, third transition series. So as they are from same group, so their electronic configuration is, that will be same kind, that is valence shell electronic configuration. So after the noble gas, it is d orbital and 4s. That means n minus 1 d and n s. Here n value is 4, n minus 1 is 3. So 3d10 4s2. Cd, it is in the next period, so that is why now it will be 4d10 5s2. And when it is mercury, now there will also be F electron. Now see, in case of Zn and Cd, you do not have any F electron, but in case of Hg, there is presence of F electrons. Now F, that is this 14F system, it is present in the inner core. That means it is n minus 2F. If it is NS. Okay, that means it is not just penultimate shell, it is pre-penultimate shell. This is the outermost shell, this is penultimate shell, this is pre-penultimate shell. Now mercury F14 system, it is present in inner core. Due to the diffused nature of F orbital, the shielding between the inner core electrons and the valence shell electrons, that will be very poor. So suppose this is nucleus, there are some electrons present, so these are the inner electrons, and outermost so if these electrons are outermost electron, though I'm doing it just in a very simple way, there will be F electrons also in between inner electrons and outermost electrons. So these 14 electrons, suppose I am writing it in red color. Now this 14F system, as it is having very poor shielding capacity, so this attraction between this positive charge for these outermost valence electrons, the attraction will be very high because screening property is very poor. Shielding between the inner core electrons and the valence electrons is very poor. So the attraction of the positive charge present in the nucleus and the valence electron, that is very high. And because of this high attraction, polarizing power is very high. Now, according to Fesen's rule, when polarizing power is very high, covalent character increases. It is directly related to polarizing power. So if the cation is having very high polarizing power, the molecule will be having covalent nature. And covalent nature means it will not produce free chloride ion. So as it cannot produce free chloride ion, so that is why it will be AgCl2, which will not be able to give positive chromyl chloride test. So this is the correct option. Is there any doubt? So this chapter is all about D block and A block, right? Now D block, that will be complete after discussing this question. This is the last question related to KMnO4 and K2Cr2O7. And after finishing this question, we will start A block elements. So see here, we have to find out three different answer because three questions are there. So what is the question? An equal volume of reducing agent is titrated separately with 1 molar KMnO4 in three different medium: acidic medium, neutral medium, alkaline medium. And for this titration, the volume of KMnO4 required 20 ml when it is acidic medium, 33.3 ml when it is neutral medium, and 100 ml when it is alkaline medium. Okay, so different volumes required. But remember, the reducing agent that you are using, though it is not mentioned which reducing agent, that is also not important. Just remember the reducing agent that is used, the volume is same. Only the volume of KMnO4 is changed. Concentration is same, medium is different. So different medium, different volume of KMnO4. First, we have to find out the oxidation state of Mn in each reduction. That means in acidic medium, KMnO4 will be reduced. So you have to find the final oxidation state after reduction. In neutral medium also it will be reduced. So you have to find the after reduction what is the oxidation state, and also for alkaline medium. And remember the equation that we have used when discussing KMnO4, that in acid medium it is converted to Mn2+. So if you can remember that equation, you can very easily answer the first question without doing any calculation. And neutral medium, and there is alkaline medium. Neutral medium it is converted to K2MnO4, and alkaline medium it is converted to MnO4. Okay, alkaline medium it is K2MnO4, and neutral medium MnO4. So depending on medium, if we know what is the oxidation state, you can easily answer the first question. But here we will try to answer the question by doing the calculation. So this is the first question, and the second question is balanced equation we have to write for all these three half reactions. Okay. And the third question is find out the volume of 1 molar K2Cr2O7 consumed if same volume of reducing agent is titrated in acidic medium. So instead of taking KMnO4, if you are taking K2Cr2O7, but reducing agent you have kept same, under this condition what will be the volume of K2Cr2O7 which will be required? That also we have to find. And it is in acidic medium because K2Cr2O7, that always it shows oxidizing capacity only in acid medium. Okay, so we cannot finish this question because it will take much time. I'm just discussing a few points. So suppose the amount of reducing agent that we are using for reduction of manganese is VML. When it is acidic medium, Mn from +7 oxidation state, it is accepting N1 number of electrons and it is converted to oxidation state A+. If you can remember that it is 2+, it is fine. But suppose if you cannot remember it, then you have to write this type of equation. So 7+ oxidation state accepting N1 number of electron and it is converted to A+ oxidation state. So we can easily write that 7 minus A, that will be equal to N1. So suppose if A is 2, suppose it is 2+. So N1 will be 7 minus 2, that is 5. Similarly, when it is neutral medium, suppose it is B plus and the number of electrons N2, and when it is alkaline medium, it is N3 and oxidation state is C plus. So these three equations we can write. Okay. So we will finish it in the next class. And until now, regarding on the slide, is there any doubt? So as there is no doubt, we are ending the session here. Thank you for listening.